Hi class, very good evening everyone. Welcome once again to Om Institute and welcome to the practice session for Engineering Services 2025 examination, which is going to be conducted just the next month. And in this session, we are going to practice the important PYQs of control systems. And because there are a lot many PYQs, of course, I'll more target towards recent year PYQs because always recent year PYQs more correlate, with the pattern and with the level of the examination. But yes, since even if you target some recent year PYQs also, there are a lot many, especially from control systems. So I'll take it in different parts. Today is the part number 1. Okay, so we'll cover up some important PYQs this part, and then we'll of course, as I'm telling you, because I want to cover wide variety of PYQs to cover wide variety of important areas. Okay, so yes guys, let's get moving ahead. Very good evening everyone. Good evening Bhadru. Good evening Rohan. Okay, so yes. Uh, I would just say, in case, of course, engineering services is coming up just the next month. But if your target is any other exam, see, engineering services in ESE is mostly having numericals, mostly. So even if your target exam is controls, is GATE or, AE or etc., if you're prepared control systems and you want to have a decent practice session, then also this particular session is going to help you. Okay, for the practice, for any other examination as well. So let's get moving ahead quickly. And before I get started, an important update about the summer short-term course. So we are today on 12th of May, and the first summer short-term course starts from 18th May. Yes, and that's an offline summer short-term course at our Hyderabad center. Yes, especially for those who cannot stay long at Hyderabad due to any of the constraint, or especially if you're college-going student, you cannot, of course, having college outside Hyderabad, you cannot stay in Hyderabad for long term. Okay, so that is why for especially those people we have designed the short-term course. The duration will be 60 to 65 days. So those much time, even if you're college-going student, if you take out of your semester break and spend daily 7 to 8 hours of classes here, okay, so you can get a good coverage of the GATE syllabus in this summer short-term course. Let me again brief you. We have told you earlier also. Okay, in this 60 days, around 50 to 60% of the syllabus will be covered in offline manner, and for rest of the syllabus, you will be given the free complimentary access to our online courses. So yes, remaining subjects, once you return after 60 days, you can cover up in the online manner, but at least 50 to 60 important and core subjects will be targeted more. Okay, and of course, concept clarity, problem solving, everything will be the target of this particular course. Okay, so there are 3 batches going to be there. The first batch starts on 18th of May. Okay, so let's get moving ahead, guys, and start with the first question. Let's get started with the first question here. The open loop transfer function of a unity feedback. So see, definitely from the fundamental time response analysis as well as steady state errors also, there are definitely questions that come up in the examination. So that is what is the first category of questions I have picked up. Good evening, Sai Vikas. Right. So the open loop transfer function of a unity feedback system is given k upon s tau s plus 1. By what factor should the amplifier gain k be multiplied so that the damping ratio is increased from 0.25 to 0.75? So fundamental question on damping ratio. Okay, see, if I start with the characteristic equation, the characteristic equation would be 1 plus dshs, 1 plus k upon s tau s plus 1 equal to 0. And simplifying this, I would be getting s square tau plus s and then plus k equal to 0. Or writing in the standard form, divide by tau, s square plus 1 by tau into s plus k by tau equal to 0. Okay. Now by what factor should the gain k be multiplied so that damping ratio? Now see, for damping ratio, let me figure out first this term. This is omega n square. So what is going to be omega n? What is going to be omega n is root over k by tau. Correct. And then this central term, the coefficient of s, we all know is 2 zeta omega n. Okay, so if I place the value of omega n, which we have just decided as root over k by tau, this is equivalent to 1 by tau. So finally, what is the value of zeta? Okay, so root tau and tau can get cancelled. Zeta can be written as 2 shifted there, 1 by 2, root k, and here also root tau. So 1 upon root k tau. Now, I am looking into the amplifier gain k. By what factor should the gain k be multiplied so that damping ratio increase from 0.25 to 0.75? Now see, what is a simple analysis that zeta is proportional to 1 upon root k, that is inversely proportional to root k. Can I say that? right? Good evening, Ramu. Okay, zeta is inversely proportional to root k. Okay, or vice versa, if I want to know about k, k is inversely proportional to 1 upon root zeta. K is inversely proportional to 1 by zeta square, I would say, correct? 1 by zeta square. Okay, so now if zeta becomes 3 times 0.25 to 0.75, that is 3 times. If zeta becomes 3 times, what should be the effect on the gain k? Okay, k should become 1 by 3 square. And what is 3 square? 9. So 1 by 9 times. And what is 1 by 9? Is 0.1111. The answer has to be option number A. Okay, answer has to be option number A. Yes, correct answer, Sai Vikas. So option number A is the correct answer. Option number A is the correct answer. Okay. Okay, then moving ahead to the next question. Here it is, a second order system with a 0 at -2 and 2 poles at -3 plus J4 and -3 minus J4. This is 2018. The previous one was 2022 question. These are the poles and zeros in the S plane. The undamped natural frequency and the damping factor. See, a simple question because the 0 also would not be required here, because if you only target about poles which are given as -3 plus minus J4 complex conjugate poles, and the complex conjugate poles for the second order control system are simply given by the formula minus of alpha plus minus j omega d, or equivalent to alpha, the damping factor is minus zeta omega n plus minus j omega d, which is omega n root over 1 minus zeta square. Correct? Root over 1 minus zeta square. Now let me tell you that there is a correction. They have written damping factor, but they have actually intended to ask damping ratio. Okay, they have actually intended to ask the damping ratio. Damping natural frequency. Yeah, correct. They have intended to ask the damping ratio actually for the system. Correct? Just a second. Okay. Now, okay. Just a second. Yeah. Yes. Good evening, Nathan. Okay, so we have some answers. Sai Vikas and Rohan saying answer D. Okay. So see, dear, very simple now. If you want to calculate, alpha, if you just correlate an alpha, which is, if you just talk about alpha, which is zeta into omega n is 3. Okay, and the question is asking about the undamped natural frequency, which is omega n, and the damping ratio, which is zeta. And what I know, the product of them has to be 3. And only, is there any option which satisfies the product of them equal to 3? Is only option number D. You can stop here, although you have two relations. Okay, from two relations you can find both. But zeta into omega n equal to 3, and that is only satisfied with the option number D, 5 into 0.6. Okay, 5 into 0.6. Only option number D satisfies. So you can, definitely take that as the answer. Take that as the answer. Correct. Okay. So yes, correct answer is option number D. Moving ahead to the next question. Okay. The output of a standard second order control system for unit step input is given to us. Okay, for unit step input is given to us. What is the transfer function of the system? Okay, what is the transfer function of the system? That is what we need to figure out. Okay, so let's check it out. Now see, if I talk about the output of a standard second order system for step input is usually given by the expression 1 minus e raised to the power minus alpha t divided by under root of 1 minus zeta square into sine of omega dt plus phi. And with a 90-degree phase difference, of course, sine can be written as cosine. Okay, that can be converted to cosine. Okay, only by this much of information you can be able to find out the answer. Why? Because if you look into this factor 1 upon under root 1 minus zeta square, what comes here is 2 by root 3. Okay, so if you take the square, 1 minus zeta square will be equal to 3 by 4. Okay, root 3 by 2 square, 3 by 4. So from here you have got zeta. Zeta square is 1 by 4, so zeta is 1 by 2. The zeta is equal to the 1 by 2, correct? Now, zeta is 1 by 2, and now look into this coefficient e power minus alpha t. Okay, the coefficient, exponential coefficient alpha equal to 1, zeta into omega n is 1, but zeta obtained is 1 by 2. So 1 by 2 into omega n equal to 1. So omega n should be equal to 2. Omega n 2 and zeta equal to half. Now omega n equal to 2. Okay. Omega n equal to 2. Only option number D. If you talk about omega n equal to 2, this itself is satisfied only by option number D. Only by option number D. Correct? Na? Nothing else required. Okay, because here omega n square will be 1 here. Okay, roots are real and distinct, so system cannot be underdamped. Zeta equal to 1 by 2 means underdamped system. Okay, so this is like roots are real and distinct, real and unequal, so it has to be overdamped system. Zeta has to be greater than 1. So A option definitely not correct. Okay, and then C option, omega n square is 3, so omega n root 3, so that is wrong. So only D option. So many times you can just by 1 or 2 parameter, maybe you can match the answers. Rohan has the answer D. Okay. All right, correct answer. Correct answer. The correct answer is definitely the D. Okay. Okay. Yeah. Moving ahead to the next question then. Have a look into this next one. The open loop transfer function of a unity feedback system is given to you. 20 upon 0.21 s plus 1. What is the time response subjected to the step input? Okay, of 0.8 amplitude. Step input 0.8 by s is given. The step input of 0.8 by s is given. Okay, and the loop transfer function is given. Okay, the loop transfer function of a unity feedback system. Now you see here, what is only given is GS, and if I talk about the closed loop transfer function, this is only the open loop transfer function given. Unity feedback is there. The closed loop transfer function would be written as, okay, the complete transfer function, I can write it this way, CS upon RS, which is equal to GS upon 1 plus GS. Since unity feedback is there, okay, so GS upon 1 plus GS, correct na? That is what we need to simplify. Okay, so what is my final closed loop transfer function? Should be equal to, substituting GS, 20 by 0.21 s plus 1 whole divided by 1 plus 20 upon 0.21 s plus 1. Okay, correct it is. Okay, so okay, so now if I simplify, so what do I get is, it's going to be 20 multiplying by 0.21 s plus 1, so 0.21 s plus 1 plus 20, so plus 21. Okay, so it's a basically first order system only. Now, what is the time response for this, input of 0.8 by s? That input is given to us. Okay, so they have called the input as xs, no problem. It can be written as ys is divided by xs. Okay, so what is going to be the final output? The final output will be equal to input into this gain. And what is the input? 0.8 s multiplied by this factor 20 upon 0.21 s plus 21. Okay, so this looks like, okay, 20 into 0.8 should be equal to how much? That is 16 divided by s into 0.21 s plus 21, which we should break into partial fraction then immediately. Correct? Which we should break into the partial fraction. So yeah. So what is the output now? Converting to time domain. Okay, let me write down this expression again. 16 by s, 0.21 s plus of 21. That was 21 only, na? Correct. Plus of 21. In fact, to make it simple, you can write this way. First of all, before taking the partial fraction, better to take 0.21 outside. So then it becomes s, and this will become 100. 0.21 into 100 will become 21. Okay, now that becomes easy for you. Okay, this constant we can divide and simplify later. 16 upon 0.21. What is now there is, okay, some a by s plus b by s plus 100. That is what you have to simplify. Let me write down the result of partial fraction directly only then. Okay, if I just take result of partial fraction 1 by s and the other term is 1 by s plus 100, you just subtract both of them, you will get 100 and then 1 by 100. Okay, so basically the output is, I hope you have understood this. Okay, because if I subtract this, s cancel, but 100 will be left, so I have divided 100. The 16 by 0.21 is outside. Now you see 0.21 into 100 again multiply. So answer is 16 by 21 and then 1 by s minus 1 by s plus 100. Okay, so what is the output in the time domain? If I take the inverse Laplace transform, it is 16 divided by 21. 1 by s means inverse Laplace 1, unit step signal, minus of what? Minus of 1 upon s plus a, e power minus at. The Laplace transform, e power minus at, correct? 1 upon s plus a. Okay, so 16 by 21, 1 minus e power minus 100t. Okay, 1 minus e power minus 100t. Or they have written as t upon 0.01. One and the same thing. Okay, one and the same thing. 16 by 21 approximately should be like 80%. Okay, 0.76. So then I will match it with option number B. Okay, that calculation part also not required. Okay, because anyways, you know that in ESE prelims you will not have the calculator, but not required also. Okay, this can be approximated as 0.76, 1 minus e power minus t upon 0.01. E power minus 100t. Correct. So correct answer is option number B. Basic question which you can handle by the Laplace transform, nothing great there. Okay. Yes, Rohan, correct answer B. Hope you have got it. Any doubts you can let me know. Correct. Let's move ahead to the next question then. Okay. So see, a basic question, a fundamental conceptual question only, 2023 engineering services. Consider the following conditions for second order system with when subject to unit step input. With critical damping, there are no oscillations. With no damping, the system output oscillates with constant frequency. Now see, one by one. With critical damping, there are no oscillations. Correct. The system becomes, for critical damping, for critically damped system and over damped system, there are no oscillations. System is non-oscillatory. Okay, so this is correct only. With no damping, system output oscillates with constant frequency and variable amplitude. Variable amplitude. See, the system output oscillates with constant frequency. No, if there is no damping, see, if there is no damping, okay, if I take the standard response of second order only or as an example, under no damping, it oscillates definitely with a particular constant natural frequency and having this maximum amplitude 0, the amplitude level 0 to 2, maximum amplitude 1. Okay, constant frequency and the amplitude is also fixed. We cannot say variable amplitude. Okay, so second is not entirely correct. With over damping, the output takes longer time to reach the steady state value as compared to critically damped. So third is also like correct statement. Okay, so 1 and 3 are correct statements. So option number D has to be marked. So in engineering services, you be prepared for these definitions or theoretical questions. Everything should be there as a part of your notes. Okay, nothing extraordinary to think, only basic fundamentals and facts. Okay, if you have revised your notes, okay, it should be able to work out. It should be able to work out. Okay, right. Acha, sorry, it has to be option number C, the conditions which are not correct. The conditions which is or are not correct, then it is C. But 2 is the only not correct. A and 3 are the 1 and 3 are the correct one. 1 and 3 are the correct one. Yes. Yes, Rohan, 1 and 3 correct. Yes, PRV, correct answer. Option will be C because the question is finally asking which of the above condition is or are not correct. Okay, so not correct means 2. That is option number C. That is option number C. Okay. Right. So moving ahead to the next one. Moving ahead to the next question. In an underdamped second order system, the time required for the waveform to go from 0.1 to 0.1 of the final value to 0.9 of the final value. Now see, this is not 100% a correct question. This is not 100% a correct question because for underdamped, the standard way, see, again, there are in different contexts, in different textbooks, some different definitions specified, but normally for underdamped system, okay, the rise time is defined as the time taken to reach from 0 to 100. See, this 10% to 90%, this 10% to 90% is the definition which is usually for overdamped. This is the definition usually for overdamped system. Okay. But underdamped, we take it mostly 0 to 100%. That is the time taken to reach the final value for the first time. But okay, if suppose some question is there, why I have still taken this question? See, if there is an official question 2022, definitely we all know that this is not peak time, settling time and final time. Okay, so peak time we know when the output reaches its maximum value, where the first overshoot occurs, where the peak overshoot occurs. That is what you can say. Settling time is the time where the output settles to a specific percentage of the output final value. Like when the output reaches more than 95% or more than 98%, you can decide that percentage. So definitely it is not that. It is definitely rise time, but not 100% correct definition. But okay, if exam question is there, you know, if they are asking about rise time, that intent is clear. You should not think and directly mark the option as A. Okay, one or two more questions around these definitions I want to show you. Have a look into this question, 2022 only. So following statements regarding the time response specifications, you have to see delay time, okay, is the time required for the step response to reach 10 to 90% or 5 to 95% or 0 to 100%. 0 to 100%. Okay, now delay time is usually the time required to reach 0 to 50%. These are the definitions for rise time. These are the, like as I told you, this is the rise time definition for underdamped system. This is usually 10 to 90% or 5 to 95% is usually the rise time definition for overdamped system. Okay, for overdamped system. Okay, now let us see what is the second statement telling. Peak time is the time required for the response to reach the first peak overshoot. Correct? First peak overshoot. Right? First peak overshoot. Okay, so this is true. Okay, time required to reach the first peak overshoot is the peak time. Settling time is the time required for the response to reach and maintain beyond a specified tolerance band, that is either 3% or 5% or maybe 2%. They just given an example. Okay, so this is also correct. So which of the statements are not correct? Okay, I don't think this question is correct because second and third, again they are asking which of the statements are not correct. Okay, first not correct. Okay, and now with first and second, see, peak time is the time required for the response to reach the first peak overshoot. Correct. First peak overshoot. Settling time is the time required. Okay. Oh, sorry. Yeah, I read it wrong. Correct. This is false only because 3 to 5% of the final value. The correct statement is final value. Correct. The correct statement is final value. Right, yeah. So that is why rereading the definition, peak time is the time required to reach the first peak overshoot is the correct definition. Okay, first one was also wrong. Settling time is the time required for the response to reach and maintain above a specified tolerance band, and that is 3 or 5% or sometimes 2% also of the final value, not of the initial value. So this is wrong. It should be final value, then it is the correct statement. So 1 and 3 are the wrong, and then option number B. And then option number B. Okay, so let me check it. Yes, Rohan, correct answer. Option number B it is. Okay. Option number B. Okay. Let's move ahead. Okay, Rakesh, yes. Okay, moving ahead to the next question. Okay, so rise time, again see, 2024, last year question only. Rise time for the underdamped system is the time required for the response to rise from 5 to 95%. See again, okay, again you see for underdamped system they have mentioned this definition. Okay, see, I told you, usually we call it as for overdamped, but okay. Next, let me read the next also. The amount of maximum overshoot directly indicates the relative 100%. Okay, higher the overshoot generally indicates a less stable system. Okay, so this is definitely correct. The amount of maximum overshoot directly indicates relative stability because again I repeat, higher system having higher and larger overshoot usually is less stable. Settling time is the time required for the response to reach and maintain within a specified tolerance band, that is either 3% or 6% of the final value is again a true statement. Okay. So, because settling time, they have this time clearly mentioned final value to reach and maintain within a specified tolerance band. No, this is not the true statement. They are telling to reach up to what? To reach up to, this is wrong. To reach up to 93% means how they should say to reach 97%. Okay. Let me read again. Settling time is the time required because otherwise options are not going to match. Settling time is the time required for the response to reach and maintain within a specified tolerance band. Okay, they have used the correct word, tolerance band. Okay, tolerance band is 3% or 5% of the final. See, usually this is a correct statement, but again, as per standard book, see, normally what is settling time? Settling time is the time required by the output to reach within a specified percentage of the final value. Now that specified percentage you could specify as 98% also, 97% also, 95% also. Okay, but usually going beyond 95% we don't talk. Okay, see, Conceptually, this is correct, but practically we don't talk. Conceptually, this is correct, but practically we don't talk about the value greater than 5%. Okay, so for that point of view, I would call it as false. For that point of view, I would call it as false. Okay, so we can take this as, if it was 5%, then we can take it as okay. Okay, again I say conceptually it is okay, but practically we don't accept that tolerance to be greater than 5%. Okay, practically we don't accept that tolerance to be greater than 5%. In fact, see why I am telling you conceptually this is correct, because in GATE examination once there was a question where they have discussed settling time with the 6% of value. Okay, 6% of the value. In GATE exam they have actually discussed that question once. So conceptually it is okay. Conceptually we can define settling time. Okay, let the settling time be the time required by the output to reach 94%. I am happy with 94%. I am happy that even if my output reaches 94% or above, okay, I will call that as settling. I will call that as steady state. And there is a question in GATE on the same concept, 6% concept. So conceptually it is correct, but practically we don't consider beyond 5%. For that point of view, I will call it as false statement. Okay, I'll call it as false statement. Okay, so what statements will be false? 1 and 3, because again I'm telling you 5 to 95% or 10% to 90% is usually for what? Is usually for overdamped. They have mentioned underdamped. So see, there is clearly contradiction in the engineering services question itself. I told you with this question itself that this is not a 100% correct question, because here they asked the rise time, okay, for underdamped 0.1 to 10% to 90%, they took it as correct, but usually for underdamped it is, I told you, 0 to 100%. Okay, but here this statement has to be taken false. Okay, because for underdamped usually we'll call it as 0 to 10%, 0 to 100%. Okay, so 1 and 3 going wrong means option number B. Okay, option number B, correct? Right, option number B. So that is what it is. For that point of view, option number C I'll say for, because of the practical limits we keep it to be 5%. Okay, practically we want the output will settle up to 95% or beyond, and we define that as the steady state. Okay, because we know the time taken to reach the exact steady state is undefined. That is t tending to infinity. That is t tending to infinity. No, Sai, because that is different. 6 by omega n for critical. I'm not talking about 6 by omega n formula. I'm talking about a question where 6% criteria. The formula that you're telling me, 6 by omega n for critical damping. The 6 by omega n is the correct formula for critical damping, but that is only for 2% band, dear. That is the formula only for the 2% band. Okay, that means the output, when the output becomes 98%, when the output becomes 98% of the final value, correct? That is the formula 6 by omega n. I am telling you, there was a question in GATE where the output, they told, okay, find a time, let the steady state be the time where the output reaches 94% of the final value. That percentage was specified. So tolerance becomes how much? The tolerance band becomes 6%. What you are telling is a different concept. That is correct for critical damping, but that is only 2% tolerance band. That formula, if you check correctly, is a 2% tolerance band formula. Okay. Next question, dear. A unity feedback system is characterized by open loop transfer function. Okay, that is K upon S, S plus 10. Okay, if the damping ratio is 0.5, okay, then the time to peak overshoot per unit step input. See, what do you need for the calculate to time to peak overshoot? TP is given by pi by omega d, or basically it is given by pi by omega d, or pi upon omega n under root of 1 minus zeta square, where damping ratio is 0.5. The damping ratio zeta is given to you already. Okay, but what we also need to figure out is omega n, and that we can figure out by the given transfer function. See, given open loop transfer function, I will convert to the characteristic equation. 1 plus GSHS equal to 0. So what do I get? S square plus 10s plus k equal to the 0. Okay, now you see this time. Okay, I'll use this term. Okay, because this is 2 zeta omega n is equal to how much? Okay, I need omega n, that will be obtained here directly only. The k will not be required only. 2 zeta omega n is 10 and zeta is given as 0.5. So 2 into 0.5 into omega n equal to 10. Okay, so 0.5 into 2 is equal to 1 only. So omega n becomes 10. And if omega n is equal to 10 there, then Tp is given by pi is divided by omega n. Omega n is 10 under root of 1 minus zeta square. Okay, so zeta is 0.5, 0.5 square 1 by 4. Okay, so this is what we need to solve down. Okay, this is what we need to solve down. Okay, this will finally turn out to be pi Okay, divided by, this 2 will cancel with 5, 5 root 3. Okay, pi by 5 root 3. Okay, pi by 5 root 3. Okay, so calculations, of course, you can complete on your own. Calculators are not there for ESE prelims, but right now, let me just write down the answer. Okay, calculations, I believe you can handle on the own. The 0.36 approximately, 0.36 approximately, option number D. Okay, option number D. Right, that is the final answer. Yes, Rohan Singh, correct. Yes, I Vikas, correct. It is option number D. It is the option number D. Next question. In a second order system has the transfer function 25 upon s square plus 8s plus 25. If the system initially at rest is subjected to a unit step input at t equal to 0, the second peak in the response will occur at, now see, okay, the time for which the second peak in the response will occur. Okay, the second peak. Okay, the first peak is the peak overshoot. Okay, the time for the second peak is given by what formula? It is given by 3 pi by omega d. It is given by 3 pi by omega d. Okay, 3 pi by omega d. Why? Because the time for any overshoot is generally given by the formula n pi by omega d, where n equal to 1, 3, 5, 7. This is generally the time for any peak, for any overshoot. For any overshoot, for any undershoot, okay, for any undershoot also, if they ask, same formula, but n is even. At even multiple of n pi by omega d, even multiple means 2, 4, 6, etc. You have the respective undershoots. You have the respective undershoots, correct? That is what is the answer. That is what is the formula to be used. Now, that means what I need is, 3 pi by omega d. Omega d again required. Okay, so we can just compare and say the value. See, what is this? Omega n square is 25, so omega n is 5. Then next 2 zeta into omega n, which is 5, is equal to 8. Is equal to 8. So how much is zeta? 8 upon 10, that is 0.5. That is 0.5. So this is 3 times, okay, 3 times pi by omega d. So what is going to be omega d is omega n, that is 5 under root of 1 minus 0.8 square. Okay, simple calculation only, because 1 minus 0.8 square will be 0.6 square, and that is under root 0.6. 5 into 0.63, correct, na? 5 into 0.6 will be 3, 3, 3 cancel, so answer is only equal to pi. Answer is only equal to pi. Yes, I Vikas, correct answer D. Yes, that is the correct answer. Okay. Yes, Rohan said correct answer. D is the very correct answer. Okay, D is the very correct answer. Moving ahead to the next one. Okay, this is a good question. This one is a good question, 2022. See, consider the system shown in the figure. What is the value of A such that the damping ratio of the dominant closed loop poles is 0.5? Okay, the damping ratio of the dominant closed loop poles is 0.5. The damping ratio of the dominant closed loop poles is 0.5. That is the question. Let us work it out. Okay, now, what is clearly the type of system going to be formed? S plus 8 into S plus 1 is definitely going to be a cubic characteristic equation, right? Is going to be a cubic characteristic equation. So what is the characteristic equation? If you start with here, 1 plus 10 S plus A is divided by S plus 1, S plus 8. This is going to be 0. This is going to be 0, correct? Right, now, if you multiply, this becomes S cube plus 1 plus 8, 9S square plus 1 into 8, 8S plus numerator, if I expand, 10S plus 10A equal to the 0. Okay, equal to the 0. Correct. So, this is equivalent to S cube plus 9S square plus 18S plus 10A equal to 0. Now, question is, what is the value of A so that the damping ratio of the dominant closed loop poles is 0.5. Okay, now, dominant closed loop poles, the zeta should be 0.5. See, normally if there is a characteristic equation which is of third order, okay, can be factorized as some s plus a, no, that a is already given, okay, some s plus alpha, suppose, multiplied by s square plus 2 zeta omega n s plus omega n square equal to 0. See, what is the basic idea I'm taking here? That if there is a third order characteristic equation, which is of course cubic, can be factorized into a first order and second order. Okay, first order and second order. And for the second order dominant poles, they have given the zeta. Okay, what is the only parameter known to you is zeta, how much? 0.5. 0.5. That means this can be written as s plus alpha into s square plus 2 omega n s plus omega n square. That leaves us with two unknown quantities. Zeta was given. So what are the two unknown quantities? One is alpha and one is omega n. Okay, so I multiply this, I just open it, s into s square s cube plus 2 omega n s square, this is s into s, plus omega n square s, plus, now coming to the next term, alpha s square, plus 2 alpha omega n s, the next term, plus alpha omega n square equal to the 0. Rearranging it, s cube plus s square terms, 2 omega n plus alpha s square terms, then s terms, omega n square plus 2 alpha omega n, omega n square plus 2 alpha omega n into s. The constant term alpha omega n square is 0. This is what I have assumed. Okay, this is what I have assumed. Now, what is the characteristic equation given? Given characteristic equation, I mean, it was not given directly, but I have substituted the values and obtained the characteristic equation. S cube 9s square 18s plus 10a. The question is a means alpha omega n square, so alpha and omega n is to be required. Okay, so 2 omega n plus alpha is 9. Number one equation, na? 2 omega n plus alpha is 9. Second equation, okay, omega n square plus 2 alpha omega n, okay, is equal to 18. Omega n square plus 2 alpha omega n equal to 18. Right, this is what is the equation to be solved. Right, if I take omega n outside from this one, so 2 omega n plus 2 alpha equal to 18. So better I'll have to substitute. I need alpha into omega n square. Can I find it directly? If I multiply by omega n square, no, I'll substitute one into the other to solve it. Wait. Okay, so we'll have to just do a basic substitution here. I will replace alpha. Okay, so omega n square plus 2. What is alpha from here? Okay, what is alpha from here? It becomes 9 minus 2 omega n. From the first equation, I replace alpha. Then omega n equal to 18. Okay, so some calculations are there with me. Omega n square plus 2, 9, 18 omega n minus 2 to 4 omega n square equal to 18. I think so. Quadratic equation is developed up. Okay, 3 omega n square, I'm sending to the other side, minus 18 omega n plus 18 equal to 0. Better cancel this 3. So omega n square minus 6 omega n, okay, plus 6 equal to 0. Okay, plus 6 equal to 0. So I'll have to figure out what is the value of omega n. Okay, minus b, that is 6 plus minus root over b square, 36 minus 4 ac, so that is 24 divided by 2 into a. Okay, so omega n equal to 6 plus minus under root of 12. Under root of 12 is 2 root 3 divide by 2. So cancelling by 2, 3 plus minus root 3. These are the possible value of omega n. This is what is the possible value of omega n. Okay, just retally the calculation once. Omega n square plus 2 alpha omega n equal to 18. So omega n square plus 2. Alpha is substituted as 9 minus 2 omega n, which is correct. Omega n square plus 2, 9, 18 into omega n minus 2, 2, that is minus 4 omega n square equal to 18. Sending this on the other side, that becomes 3 omega n square minus 18 omega n plus 18. Okay, So 3 I cancelled and 6, correct. So looks okay only. Okay, this looks okay. 3 plus minus root 3. Okay, right. 3 plus minus 18. Okay, 3 plus minus root 3, I'm sorry. Okay, so that is 3 plus minus root 3. Okay, 3 plus minus root 3. Omega n obtained is 3 plus or minus root 3. Let us see. We'll come to alpha also now. And what is alpha? Alpha is equal to 9. From here I have written alpha is equal to 9 minus 2 omega n. Okay, that is alpha. And the final value is alpha into omega n square. Okay, let us see which of the option is actually going to match. Alpha into omega n square. So alpha can be 9 minus 2, 3 plus minus root 3. So this becomes 9 minus 3, 9 minus 6, and then this is minus plus 2 root 3. So this is 3 minus plus 2 root 3. Okay, so there are two set of values with me. So if alpha is 3 minus 2 root 3 corresponding to the first value, then omega n I have taken as 3 plus root 3. And if omega n is taken as 3 minus root 3, then alpha will become 3 plus 2 root 3. Question is 10, the value of 10a, then we'll find a also. 10a is equal to alpha into omega n square. Right, alpha into omega n square. Correct. Alpha into omega n square. Yeah, steady state value will not affect. That is what we have to take care when we neglect the insignificant pole. They have told you that this has to be dominant. This has to be dominant. Okay. Right, but what is the characteristic equation? What is the characteristic equation in front of us is cubic. So I'm comparing this cubic equation with what can be a general cubic equation. With what can be a general cubic equation. Okay, so this is alpha into omega n square. So okay, so it leads us again to a detailed calculation. Okay, so I think from here you can just calculate and complete. Okay, rest of the, this is definitely a time taking question. This is definitely a time taking question. Okay. Definitely a time taking question, right? Okay. No, see, what you are trying to neglect, no, Sai Vikas, that you can't do directly. Why? Because you are trying to neglect the s plus 8 term from this transfer function. Are you getting it? You are trying to neglect the s plus 8 from this transfer function. But whereas the question is telling the dominant poles are the poles, means poles of what? Poles of the closed loop transfer function. You are trying to neglect s plus 8 from the open loop transfer function. You are trying to neglect s plus 8 from the open loop transfer function. So from that you will not be getting the answer. Okay. Right, if the closed loop transfer function was given and then they mention that the second order poles will be dominant, then I can neglect, but the closed loop transfer function is not given. Na? Okay, the open loop transfer function is given. The open loop transfer function is given. Okay, and if you see in the open loop transfer function, okay, in the open loop transfer function, then there will not be any, underdamped condition. There will not be complex conjugate poles as well. So that is what is not the correct logic. Your rule is correct. Okay, if you have to neglect, we'll take 8 common and all, but that is, you are thinking only with respect to the open loop transfer function, right? Think in that way. Correct, Sai Vikas? Okay, correct, Sai Vikas. So this is what it is. Some calculative part is there that you can deal on and complete the answer. Okay, that you can deal and complete the answer. Okay, because rest all everything has been in place only. No further issue that I see. Just recheck the equations that I have written. I have given you how to solve this question. Okay, how to solve this question numerically. How to solve the question numerically. Okay, dear. Going to the next question then. Okay, what are the steady state errors for the inputs of 3ut, 3t ut and 3t square ut respectively of the system shown in the function, where the function ut is the unit step input. 2024 previous year double question. Now if you see what is the type of the system, it is clearly a unity feedback system. It is clearly unity feedback system. So I can define the type of the system. And what is the type of the system? Are there any poles at origin? No. Okay, type is the number of poles of GS at origin. Type is the number of poles of GS at origin when the system is in unity feedback. So there are no poles of GS at origin. It is type 0. This one is known as the type 0. correct? This one is known as type 0. Okay. Now you see, if this is type 0, what is the steady state error? What is the steady state error for unit step input? Okay, will be finite. Okay, for unit step, but there are two answers which you don't need because it is type 0. The steady state error for unit step input is 1 upon 1 plus Kp, where Kp we will find out. Okay, but for unit ramp and for unit parabolic, any higher order input, type 0 only step input will give the finite error, any higher order input will give the infinite error. Okay, and that leads to option number A. Finish. Why to solve? Option number A. Okay, some finite answer. For unit step, for 3 UT, it will not be this one. For 3 UT, it will be 3 upon 1 plus Kp. That also you have to take care. If the input is 3 UT, error also amplified because of the linearity property of the system. Okay, so 3 upon 1 plus Kp. But that is also not required because for ramp and parabolic, it has to be infinite. This is ramp input. Okay, this is parabolic input. This is ramp input. Okay, so some constant and infinite option number A. That's it. That constant also you can find out if you want. Okay, what is there in that? You can find out easily. Okay, you can find out easily. Next question. See, same year, doubly, same branch. You see the question. Doubly 2024, doubly 2024, two questions on the same concept, on the same theme, only data change. Okay, only data change. Okay, okay, again, same unity feedback configuration given, only thing is it is type 1 system. Okay, so type 1 system means steady state error for unit step would be 0. It will give you a finite non-zero error for ramp. For unit ramp, it is 1 upon kV, and for unit parabolic, it is infinity. So answer sequence should be 0, finite and infinity. 0, finite and infinity. 0, finite and infinity. Option number B. Here it is. Option number B. Again, visual question. Okay. Only thing is here for 4 UT it will be 0. For 40 UT, this is what you have to think. Okay, for 40 UT, if you are actually calculating, it should be 4 upon kV. I have written the result here for unit ramp. Okay, but for 40 UT, that is 4 times ramp, the error will be 4 by kV. Okay, the error will be 4 by kV. That you have to take care. Okay, that kV you can find. You know how to find kV. You know how to find kV. Limit of s tending to 0, s into gs. Limit of s tending to 0, s into gs. Not required, so don't complete. Okay, previous question, if you were to complete, you have to find Kp. And what is Kp? Limit s tending to 0 of gs. Correct. See, same year, two questions on the very same concept. Okay, on the very same concept. So this is the answer B. Yes, Rohan correct, Hovant correct. Option number B, it is simple. Next question, 2022 double E question. What it is, in the feedback control system shown in the figure, ds is the step disturbance, rs is the input, and cs is the output. The steady state error component due to step disturbance. See, so now we are going to calculate steady state error, okay, due to step disturbance. Okay, when the disturbance is unit step, and unit step in Laplace transform will be 1 by s, and when you are calculating error due to step, okay, automatically you will take, okay, the input to be 0, Laplace also will be 0, because we are calculating the error component due to step disturbance. Due to step input, sorry, due to disturbance input, you are taking the actual input, you will take it as 0. The actual input that you are going to take it as 0 only, right? Okay, that you are going to take it as 0. Okay, this is due to step disturbance. This is due to the step disturbance. Okay. So then what is the error definition? Okay, see, error is defined as, what you have to calculate, the definition of error will not change. What is error? It is defined as the difference between the reference input and the obtained output, RT minus CT. It is RT minus CT, but since you have taken RT 0 or RS 0, error will be minus of CT. Error will be minus of CT. Okay, and as soon as you take RS equal to 0, you will have what type of picture in front of you? See, you will have what type of picture in front of you? This is the plant gain, suppose G2. I'll make a simplified picture here, G2. This is your output C. Okay, this is your output. See, see, very clearly mentioned also, even if not mentioned, but they are clearly mentioned here. What is the error signal? It is the difference between RS and CS, R minus C, but R will be taken 0, so you will have to calculate minus C. That will be the error. But due to what? Due to step disturbance. Okay, so now see, this is G2 and this is the output C, and then since R is 0, okay, you can adjust this minus gain here or to the gain of the next controller, and that is minus 10. This gain will become minus. This minus has to be adjusted. Na? Okay, R is 0. This is minus ES into 10 or minus ES into 10 or minus 10 into ES. I adjust this minus here. Okay, and then this goes to, then this goes to this summing point where the disturbance signal D is applied. Okay, where this is applied. Okay. Okay, so what is the output C then equal to? Or we can write down C by D here. Okay. What is going to be the C by D ratio? Okay, considering D as the disturbance input. Okay, the forward path gain G2 divided by 1 plus, it looks like positive feedback, but the feedback gain is negative. So 1 minus of G2 into minus 10. Okay, 1 minus GS HS. 1 minus GS into HS. HS is minus 10 here. Okay, why 1 minus? Because this here looks like positive feedback. Okay, so it is ultimately G2 upon 1 plus 10 G2. Okay. G2 upon 1 plus 10 G2. Okay, G2 I can substitute then is 1 upon, or we will do it later only. Okay, so what is the output C? It is equal to D into G2 1 plus 10 G2. Okay, what is the, now, what is the steady state error? See, steady state error is limit T tending to infinity ET. Or by the final value theorem, we all know that it is limit S tending to 0, S into ES. Okay, S into ES. This is then equal to limit of S tending to 0, S into ES. As I told you, what is the ES? It is going to be minus of CS. Okay, in Laplace domain, the error is minus of CS. Okay, and I have that CS expression. So this is minus of CS. I will start substituting CS now. What is D? D is 1 by S with the value of D. D means disturbance, which is the step input. Step disturbance is given. So S tending to 0, S into minus of CS, that is minus of 1 by S into G2. I'll substitute G2 now. 1 upon S, S plus 40 divided by 1 upon 1 by S, S plus 40. Okay. So then this initial S and S got cancelled. This is minus, I take outside, limit of S tending to 0, S plus 40 multiplied throughout. So 1 upon S, S plus 40 plus of 1. Okay. Yeah. So minus of 1 upon 1. This is 0. So minus 1. The answer has to be minus 1. Did I miss anything? That 10 factor was, oh, sorry, this is 10. I missed this factor, 10 G2. So here it becomes 10, 1 upon minus 1 by 10, minus 0.1, minus 0.1, option number A. Option number A. Correct answer, Sai Vikas. Option number A, minus 0.1 it is. Okay, minus 0.1, option number A. Option number A, very correct answer. Okay, minus 0.1. Okay, moving ahead to the next. If all the roots of the characteristic equation have negative real part, okay, again a fundamental definition question talking about stability. Okay, yes, Rohan, A answer correct for the previous one. So if all the roots of the characteristic equation have negative real part, then the system is what? Stable, na? All of them have negative real part, that means all are in LHP. Okay, so the system is purely stable. Next question. If any root of the characteristic equation has a positive real part, or if there is a repeated root, okay, no, positive real part, okay, means RHP root, or if there is a repeated root on the j omega axis, both of them corresponds to an unstable system. Both of them corresponds to an unstable system. This is option number D. Okay, again 2020. Both of them EC 2020. See, sometimes in the same year, like I have shown you, EE 2024, this is EC 2020, repeated pattern question. I mean, repeated concept, not 100% question same, but stable and unstable condition, basic condition. Next one. While forming a Routh array, 2017 question it is, The situation of rho of 0 indicates what? Okay, the situation of ROZ, when there is an entire row of 0, system can never be stable. That is sure. It may be unstable or marginal, or it may be unstable or marginally stable. It can never be purely stable. But yes, whenever there are row of 0, the system has symmetrically located roots. Symmetric with respect to what? You can mention that symmetric with respect to the origin. Okay, the roots of auxiliary equation, which is formed by the row of 0, by the row above the row of 0, okay, always will have symmetrical roots with respect to the origin. With respect to the origin. Okay, the simple question. 2023 for the 2023 EE, for the closed loop transfer function as a part of the necessary condition for stability of linear feedback system, the characteristic roots must satisfy the following condition. As a part of necessary condition. Okay, as a part of necessary condition, it should have no nil solution, it should have no conjugate, pure complex roots, all the roots must be negative. All the real roots, must be negative. Definitely correct. Okay, see, characteristic roots must satisfy the following condition for stability. Okay, for stability, right? Okay, so definitely, see, look into this. No conjugate pure complex roots. Nil solution means at origin. Okay, no conjugate pure complex roots. See, if there are complex conjugate roots, okay, pure complex means sigma plus j omega. But if there are pure conjugate roots, both are in LHP, then the system can be stable. Okay, so this is not a necessary condition. This is not a necessary condition. If the roots are real, they must be negative. LHP is a necessary condition. Okay, no nil solution, no origin root is again a necessary condition. Okay, so option number 1 and 3, I mean, they are asking correct or incorrect? Correct only. So 1 and 3, that is option number C. Statement 1 and 3, option number C. Okay, option number C, it is correct. Right? Option number C. No, Rohan Singh, it is not B, it is option number C, 1 and 3. Okay, there is nothing like no conjugate pure complex roots. Okay, there can be conjugate pure. Sai because also says B, no, where is the condition? Why is the B condition? What is the confusion? Sai because also says B. That means you both are taking 2 as the correct. Why this is a necessary condition? You tell me. No conjugate pure complex roots. Pure complex roots. Okay. Pure complex roots. Okay. No conjugate. See, conjugate pure complex. See, now pure complex necessary is not see, no nil solution means I'll talk both about 1 and 2. What is the meaning of nil solution? Nil solution means origin. Now when there is a single root at origin, what will happen? I'll explain you. If there is a single root at origin, what will happen? See, and if you are trying to find a step response, how do you find a step response? Input into gain, and the gain has one root at origin. Understand one also. Then I'll come to 2. Okay. No nil solution. Nil solution means origin. Zero solution. Okay. Zero solution means origin. Okay. So 1 by S into 1 by S. Okay. 1 by S into something. Right. So now what is this? This will become, I'm trying to find what? I'm trying to find step response. So for step response, the transfer function of the system, which can be having some numerator also, no problem, into the step input. Step input is 1 by S. Now, when you are trying to calculate output, it becomes 1 by S square. Okay, it becomes S square. It is having some S square term. And when you break it into partial fraction, you all know what is going to happen. A ramp term is going to come up. Okay, a ramp term is going to come up. Okay, a ramp term is going to come up. Okay, that is why system, now output at t, ramp means the unbounded output. What is ramp? It is t into ut. At t tending to infinity, output will be unbounded. That is why we don't consider a nil solution, means solution at origin. Okay, the system cannot be purely stable there. And what we are asking, okay, as a part of stability of linear. Okay, this is the option number 1. Okay, so 1 is correct. Okay, 3 is anyways correct. Now 2, no conjugate complex roots. Okay, no conjugate complex roots, right? Okay, pure. Okay, pure. See, okay, pure imaginary if they mean. No conjugate pure complex. Okay, pure complex, if you want to take, see, then they should mention, yeah, pure imaginary. Okay, pure complex means let's take it as pure imaginary. Then this is not definitely a required condition. Okay, then this is not a necessary condition. Okay, so which of the following, this is correct? No nil solution is correct. Okay, then this is also correct, because if you take it as pure imaginary roots, then this becomes correct. This becomes a necessary condition, because with pure imaginary root, system can be maximum marginally stable. Maximum marginally stable. Okay, right. So then it will be 1, 2, 3. Then also it's not going to be C. Okay, that is why I explained you first one. That is why I explained you first one. Okay, so then it is D. 1, 2, 3. We'll take all three. No conjugate pure complex. Okay, I just focus on the complex word. No conjugate pure complex roots. Okay. Right. Yeah. I didn't focus on the word pure complex. I just was focusing on complex. Okay. So conjugate complex roots can be there. Pure conjugate, pure complex should not be there. Is it now okay? Then we will mark the option number D. Okay. Then we'll mark the option number D. 1 is anyways, I explained you why 1 has to be taken here. There's also a necessary condition, no root at origin. Okay, now Rohan and Sai Vikas. Okay, then we'll take 1, 2 and 3. 1 is anyways there. 1 is anyways there. Okay. Next question. Okay. With what is or are the values of K for which the system is stable for the characteristic equation? The system is stable for the characteristic equation given. Tell me. Now, 2024 double equation. 2024 double equation. What is there in the question? It's a second order. Okay, and it's a direct question. I would say for second order, what is the condition for stability? No need to go for Routh-Hurwitz also. For second order, no need to go for Routh-Hurwitz also. What you can do is, for second order, if all the coefficients are of same sign, then the system is stable. For second order, there is no Routh-Hurwitz condition required. You can apply, but not required. For higher order, third and fourth, Routh-Hurwitz should be applied. Okay, so what can I say here? This is 1. This is minus of K plus 2. So this is already positive. We start with positive. So minus of K plus 2 should also be positive. Okay, this should be positive. And then 2K plus 5, the next coefficient, 2K plus 5 should also be positive. Okay. Okay, so option number A itself. Option number A itself, both the conditions are there. Okay, because if you want to elaborate more, K plus 2 positive means K plus 2 is less than 0. Minus of K plus 2 positive, so K plus 2 will be negative. That means K less than minus 2. Okay, K less than minus 2. And from here, okay, K is greater than minus 5 by 2. That is minus 2.5. Okay, then also what is the correct answer, A or C? Then also the correct answer is A, because this word, we require both of them. Here the word is or, that is wrong. So option number A. Option number A only. Okay, after solving them, they have written both the conditions in C, but that is or condition, not or. It has to be, and only. K less than minus 2 and K greater than minus 2.5. Okay. Right. So that means if they ask you the entire range of K also, I have K less than minus 2. At the same time, K greater than minus 2.5. That means the range of K is minus 2.5 up to minus 2. If they ask you the entire range, that also is a possible question. Na? Okay, so minus 2.5 to minus 2. Okay. Next one, 2023 double E. 2023 double E. The Routh array of an open loop transfer function of unity negative feedback control system is as given. Okay, the system is stable and unstable when the values of K are respectively what? We can directly find out the range of K for stability. A Routh array is completely given to you. A constructed Routh array has been given to you. Okay, we'll just inspect the first column. This is positive, this is positive. So I have to ensure that 32 minus 4K, 32 minus 4K, denominator 3 is anyways positive, so I have to ensure this has positive. That means 32 greater than 4K or K is less than the 8. K is less than the 8 for stability. Okay, and at the same time 1 plus K has to be positive and K must be greater than minus 1. Okay, the range of k for stability is -1 to 8. Now you see, for stability k should be less than 8. Okay, that is 6 is possible, and for k greater than 8, okay, the system is stable and unstable. So there are two possibilities coming, or what? I will have to reconfirm anything. No. Let me just check it again. 32 minus 4k has to be positive, correct? Only 32 greater than 4k, so k is less than 8. At the same time, 1 plus k has to be positive, so range of k is -1 to 8. Okay, the Routh array of open loop. Okay, forget, you have to do, you don't have to solve it this way. What is the catch in the question? See, what is the catch in the question? There is the Routh array which is for open loop transfer function, got it? That is why the answers will not match. There is the Routh array for open loop transfer function given, and the system is stable and unstable. Okay, so now when they say system, what it should mean? It should mean the closed loop system. By default, it should mean the entire system. They have given the unity feedback also, unity negative feedback. That means open loop transfer function means only GS. There is no HS here. HS equal to 1. Correct? HS equal to 1. So this is what is the point to be careful. So what is that equation? What is that open loop transfer function? Okay, how can I express the open loop transfer function? That can be noted from here, na? Okay, at least that can be noted from here. Okay, that is what you have to figure out. Okay, that is what you have to figure out. The value of k that was coming -1 to 8 will be the range of k for the open loop system to be stable. That will be the range of k for the open loop system to be stable. Okay. Yeah. So this can be the open loop transfer function, and then again, even if I express that as open loop transfer function, there will be difference of unstability, I think. See, what is given to me, the closed loop transfer function will be written as g upon 1 plus g. Okay, where my characteristic equation is 1 plus g equal to 0. 1 plus GSHS equal to the 0. Okay. 1 plus GSHS equal to the 0. That is what my final characteristic equation will be. And this itself will be the characteristic equation corresponding to the GS function only, na? Routh array of open loop transfer function. That means how the G should be. Okay, if I have to form the equation, this becomes s cube plus 6x square plus 12s plus k, 8 into 1 plus k equal to 0. 8 into 1 plus k equal to the 0. Correct, na? Okay, and this should be the characteristic equation corresponding to GS. That means how the GS should be some numerator part upon this s cube plus 6s square plus 12s plus 8 into 1 plus k. This is what this question would actually take you towards. Okay. Let me assume that there are no zeros. Okay, let me assume that there are no zeros. Let me consider this only. Let me assume this only. Then if I have to form the entire characteristic equation, that is again I am assuming that there are no zeros, which will be 1 plus GS equal to 0. So that will give you s cube plus 6s square plus 12s plus 8 1 plus k plus k. Okay, so that should become 8 plus 8k plus k, that is 8 plus 9k. I'll have to retry with this. Okay, I'll have to retry with this. S cube plus 6s square plus 12s plus 8 plus 8k plus 8, that is 8 plus 9k. So if I have to retry with this, so what are the coefficients now? 1 and 12. This is same, and for s square it is 6 and then 8 plus 9k. 6 and 8 plus 9k. Okay, this becomes s power 1, that is 6 12 72 minus 8, that is 64. 672 minus 8, 64, and minus of 9k divided by 6, and this is 0, s power 0, x into k by x. So 8 plus 9k and 0. Okay, and 0. And by looking into this also, there will be a similar result only coming up with little bit values change. 64 plus 9k greater than 0. K should be less than 64 by 9. That is roughly 7 point something. Then also it is not going to perfectly match na. See, I think there is something which is not matching with the data. Either something is not matching with the data. They give the Routh array of open loop. Okay, even considering that also, the range of k for stability earlier also was coming to be k less than 8. Okay, either they have to mention unity negative feedback, that is what is mentioned clearly. Or any calculation error happening, I don't think so. All that is fine. 32 minus, here also 64 minus 9 into 6, positive only, 9 into 15. Guys, I'll recheck this question. Maybe, maybe there is some error. There's something I need to recheck with the question. The data is not being consistent. The data is not being consistent. Okay. The data is not being consistent here for sure. Okay. Okay, so I'll recheck this. Okay, I'll have to recheck this. Correct. Take this as 9 also. Yeah, I'll recheck this. Okay. Yeah, that's what I'm doing. That's what we have done, Rohan. We have figured out CLTF or characteristic equation. Okay, so either options are wrong or maybe some numbers are wrong. Okay, no problem. But I have explained you the concept. Okay. Yes. Okay. Yeah, that is correct, Rohan Singh. They have very clearly mentioned it is open loop transfer function Routh array from which we can think about CLTF or direct final characteristic equation. That is what I have tried to done here. Okay, but still there is no option that is matching. Okay, so I'll recheck this question whether there is a typing error. Maybe the question was correct here. I've got some typing error. I'll check it and I'll update you. Okay, so this is one of the theme of the question that I've taken here. Next question. Okay. Consider the stability of the system shown in the figure when analyzed with the positive real value of gain k. Okay. In the open loop configuration, in the closed loop configuration, which of the following statement is correct? Both 1 and 2 are stable or unstable. 1 means open loop configuration. Okay. So see dear, that we can directly say here. What are the open loop poles? Okay. In the open loop configuration, there are poles at 0, 0, minus 2. Origin pole, that too repeated origin pole, unstable. Unstable. Okay, it is unstable. Got it? Okay, so first is definitely unstable. Now in closed loop configuration, I will start with the characteristic equation actually. So 1 plus k s plus 1 upon s square s plus 2 equal to the 0. So what do I get? Cubic equation s cube plus 2s square plus ks plus k equal to 0. S cube plus 2s square plus ks plus k equal to the 0. Correct? Okay, now see, before I solve you, I just want to tell you, in general, there can be many questions around cubic equation. Okay, if you know it, very good. Otherwise, generally cubic equation, if you have as cube plus bs square plus cs plus d equal to 0. Okay, of course, for cubic Routh array is required, but applying it once, you see the very simple condition. Okay, you see, now, alternate coefficients AC and then BD. When I start the S power 1 row, I get BC minus AD, correct? BC minus AD upon B, last element 0. S power 0, this factor, suppose x into D by x, it will be D and 0. Of course, I have assumed that all A, B, C, D are positive. So A positive, B positive, D positive. You have to ensure BC minus AD also positive for stability. Okay, so BC should be greater than AD. The product of inner terms should be greater than the product of outer terms. Remember it simply. Okay, remember it simply, right? Remember it simply. Okay, so what is the inner term? See, for stability, this inner term should be greater than outer terms. Okay, so 2k, you want the system to be stable, and this is going to be stable if BC greater than AD, and then vice versa. If BC less than AD, then unstable. Equal to means marginally stable, boundary value. Okay, so BC should be greater than AD. Now, what is BC here? 2k. And what is the AD here is k. 2k should be greater than k. So bring the k on the left side. That means k, okay, should be greater than how much? K should be greater than 0. And that is already given, I think. That is already given. There is a positive value of k, positive real value of the k. So this is correct. Okay, so 2 is closed loop. It is stable. Okay, 1 is unstable. Okay, 1 is unstable, 2 is stable. Okay. No, Sai Vikas, you are telling reverse. Open loop is unstable. Clearly, for open loop, you need the open loop poles which is available, na? Which is available. Okay, so open loop unstable, repeated, that to repeated at origin. Okay, so open loop unstable clearly, and the closed loop is stable for k greater than 0, and that is already mentioned in the question that yes, k is greater than 0. Okay, so correct answer C. Yes, Rohan, correct answer. It is option number C. It is the option number C. First, open loop unstable, and second configuration, that is the closed loop, will be stable. Okay, the closed loop will be stable. Next one. Okay. Now see 2021, but on again, if you try to form the characteristic equation, okay, this is open loop transfer function. What is the characteristic equation? 1 plus open loop gain, 1 plus GSHS. So 1 plus K, 1 minus S upon S square plus 5S plus 9 equal to 0. So solving it, S square S cube, then plus 5S square plus 9S plus from the top K minus Ks equal to 0. So rearranging S cube plus 5S square plus 9 minus K into S plus K equal to 0. Okay, maximum value of K for the closed loop system to be stable. Okay, cubic equation stable. Okay, if inner, that is 5 into 9 minus K. Okay, BC minus AD must be positive. BC greater than AD. Okay, so greater than A into D, which is K. So what I want here, 5, 9, 45 minus 5K greater than K. Okay, that means that goes there. 6K is less than 45. So K is less than 45 by 6, which should be 7.5. The maximum value 7.5. Actually, at 7.5, it will become marginally stable. Okay, but yeah, that is what you can say as the maximum value of K for the system to be stable, or worst case, marginally stable. So option number C in this case. Again, a direct question I told you, from the cubic equation. From the cubic equation, another direct question only. Okay. Next question. For the unity feedback system, the range of K. See again, cubic equation again. What is the cubic equation? What is the characteristic equation? 1 plus K upon S, S plus 1, S plus 2 equal to 0. See 2024 question. S cube plus 1 plus 2, 3S square plus 1 into 2, 2S plus K equal to 0. Okay, so for stability, BC, that is 3, 2. Okay, should be greater than 1 into K. So answer is K less than 6. Answer is the K less than 6. And of course, positive. Okay, all these coefficients I told you, A, B, C, D must be positive. This K must be positive also. Okay, and at the same time less than 6. Same time less than 6. Okay, so I told you, even in GATE also, this cubic equation makes a very common question. So that is why, not for others, but for cubic at least you can remember, inner greater than outer for stability. Vice versa, unstable. Boundary condition BC equal to AD is marginally stable. So BC greater than AC is an important condition. Okay, this is important. Next question. The system represented by this equation, okay, is stable, unstable, having what? This is the characteristic equation of a system given to us. Okay, so we'll definitely have to go to the Routh array to deal with this question. Okay, so what are the alternate coefficients? 5, 12, 100 and 200. Okay, I'll start with S power 6 row, 5 and then 12, 100 and 200. and then S power 5 coefficients, which are 8 and 20 and 150. 8, 20, 150, and then 0. Okay, and then 0. Right, so what is going to be the S power 4 row? Okay, so this is 8 into 12, 96. This itself is going to be negative, I believe. 8, 12, 96 minus 100, to minus 4 by 8. Okay, and then minus 1 by 2. Okay, we'll simplify later. 8 into 100, 800 minus 750. Okay, 800 minus 750, that is 50. 50 by 8. 8 into 200 by 8. So let this be 200 by 8. So what I can do, dear? Okay, what I can do for simpler calculations at the next step. For simpler calculation at the next step, better to multiply throughout by 8. Okay, I will suggest better to multiply by the 8. Okay, if you multiply by the 8, okay, I can take this row as what? Minus 4, 50 and 200. I can call this as minus 4. I'll call this as 50, because you can multiply by any constant, by any positive constant to any row. Divide or multiply. Okay, now S power 3 row. So definitely it is unstable. Sign change has come. Minus 80 minus 400. So minus 480 divide by minus 4. I will simplify later. Minus 600 and minus how much? 1600. Minus 600 and minus 1600. Correct na? 600 and minus 1600. Minus 2200 upon minus 4 and 0, 0. Okay, 0, 0. So both of them are actually positive, and I'll multiply by 4. Okay. In fact, 480 can be taken common. Calculations I'm doing, okay, because 480, no, it's not perfectly common. It should be then, okay. So I'll write it this way only. I'll take at least, minus is not there in both. 4 I'll multiply. So 480 and 2200. Okay. 480 and 2200. At least something I can take outside, na? Okay, let me take at least 2 outside or 20 outside. I'll divide so that the next step calculation is simpler. Okay, so if you take 20 outside, it becomes 24. If you take 20 outside, this is 110. In fact, take one more 2 outside, to 12 and 55. So divide by 40. Better is divide by 40. So see, if you divide this by 40, you see here once again with me. If you divide by 44, cancel. 48 by 4 is 12. So I will write down here 12. Divide by 40 here, so how much it is? 220 by 4, so this is 55. Okay, now next, S power 2, 12 into 50, now this is okay, 60, 600, 600 minus, it becomes plus, how much? 600, correct na? This is correct, plus 220, okay, plus 220, this is also okay now, so that becomes 820, okay, and divide by 12, we'll deal later, 12 into 200, okay, 12 into 200 divided by 12. Okay, will this be cancelled? Not perfectly cancelled. So this is 12 into 200 divided by 12. Let it be like this only. Okay, so yeah, that's definitely going to be calculative only. Okay, so now I'll multiply by 12 throughout. Okay, so 820 and 12 into 200. 820, 12 into 200, that is 2400. Okay, again, if you want, you can cancel out how much? Cancel out at least 20. If you cancel out 20, cancel to 82, 82 by 2, 41. Cancel out 20 from here to 120. Okay, S power 1 row. Okay, so now it's going to be positive or negative. See, this is going to be 41 into 55. I'll write down the values here. You keep solving 2255, and this is now again positive. Na? This is, okay, this is some positive value only. Okay, this is some positive value. This is definitely 0. So there is no sign change going to come up. No need to write down. This is 2000s and this is 1440. Okay, so not required. S power 0. This positive value into 120 by positive value. So 120. Okay, so this value not required. Okay, this value not required. Okay, forget this. Okay, so now it is definitely unstable, that I cleared. Okay, but how many poles in the right half plane? There are 2 sign changes. Sai Vikas has the answer. I'll just read that. Okay, there are 2 sign changes. So it is unstable. Okay, having 2 poles in the right half of the S-plane. Answer is D. Yeah, Sai Vikas has made it D. Correct. Yes, Ricky will plan that. Okay, so it is option number D. Unstable with 2 poles in the right half of the S-plane. A calculative question, I would say, not difficult, but yeah, definitely little calculative. Okay, little calculative and time taking. Okay. Also guys, the next set of information for you is if you are planning to prepare for any AE or AEE examination. Okay, so the new batch for AP Transco, AP Discoms as well as TG Transco and TG Telangana Transco and Discoms, okay, starts from 13th of May. Okay, that is just tomorrow, the 13th of May, right? At the same time, the offline regular batch, okay, for GATE new batches, the offline regular long-term batch and the summer short-term course starts on 18th May. Okay, starts on 18th May. Okay, the fee for the complete long-term course is 54,999. For the summer short-term course is 45,000. Okay, and with the summer short-term course, as I mentioned in the beginning, that this is only a 60 days course, but after 60 days, you are still given the free complimentary online access, access to the online course of the OM, live as well as recorded till the GATE 25 examination. And this is the long-term course where you subject all subjects, in the offline manner only. Okay, and of course there are special discounts like 50% off for IIT and IT students. Okay, and as well as BIT students here, 50% off for OMOL students, 30% for triple ITs and state government university students. Okay, dear. Right. In any cost, whether for short term or long term, you cannot travel to Hyderabad and want to still prepare the GATE, still want to prepare for GATE by sitting in your place at your hometown and want the guidance from the best faculty team for ECEE in the nation, that is the OM Institute faculty. So you can have the access to our own online live batch. Okay, you can have the course for GATE 26 1-year validity. The fee is 19,999, or you can also purchase the course long-term course for GATE 27 with the 2-year, that is 24 months validity, 28,999. All right, for any more details, you can visit our website or contact our support numbers. Okay, thank you guys. I'll share you the PDF of today's session. Okay, I'll share you the PDF in my Telegram group. Okay, and as my rule, my PDFs will always be password protected, because those who have the dedication to learn, watch, sit and learn, they only need the notes. Okay, this class notes means you really wanted to attend the class, you have learned something, and then you need the notes for revision. Okay, to see how I have solved, because already the solutions are there, but later on you can refer. Okay, so I'll be giving the PDF in my Telegram group. Okay, that will be password protected with the password stable, everything in small. Please, you can note down the password. I'll share the PDF in my Telegram group. Okay, this is what is the name of my Telegram group. If you are already connected, well and good, or you can join, you can search by this name. Okay, and I'll be sharing the PDF which will have this password. You can note down the password, because once I share the PDF, I'll share you the PDF tonight or tomorrow morning. Okay, I'll try for tonight, otherwise tomorrow morning. Okay. Yes, I Vikas, I'm planning evenings only, probably same time. Okay, we'll take again control system part 2 also. Okay, where we'll more talk about Bode plots or Nyquist plot type of question. We have taken some questions from time response, steady state errors, and Routh Hurwitz basically, but Bode and Nyquist, all that also I'll take. Okay, so next session will be control system only, evening time only will plan. The timing will mostly be the same, 8 PM types. Okay. All right, dear. Okay. So see you with another session of control system, and then after that we'll plan signals and maths as well. Okay. Okay, so I'll update you in my Telegram group about the next control system. Okay, that will be tomorrow or day after tomorrow only, Tuesday or Wednesday. Okay, within next 1 or 2 days only, I will first take control system, then we'll start another subjects. Okay, bye bye. Thank you. Stay safe and take care of yourself.